All right, we are moving on to more division by decimals. This lesson is called dividing by tenths. So remember, the tenths place is that first place to the right of the decimal point. Our lesson tomorrow will actually be dividing by hundredths. So we're kind of just going to focus on those two the rest of the week. But let's get into a warm up. And for this one, um, it wants us to draw a number line. Don't really want to do a number line drawing at this point. What I do want to do is take this equation, 4 tenths times 6 equals 2.4. And I want to change that into a division problem. And again, this is just a review of how we do that. So, um, first thing I'd like to go over is um, these are factors, and we talk about um, multiplying. We've got that. We've got our full factors are the numbers that we multiply together, and the answer we get for our multiplication is a product. Now, all those terms change when we take these numbers and put them in different order for division. So, um, to do a division, you can take your product, which is 2.4, and that's going to be your dividend. And then what's cool about this is you can take either factor and use that as your divisor. So, for example, 2.4 divided by 6 equals 4 tenths. Or you can, let me grab a different color here. You can make your dividend 2.4 divided by 4 tenths, and that will equal 6. So you can flip flop your factors either way when you're doing that. Your product, though, always defaults to the dividend. So just remember it's like that. Don't always just I guess what you can think of if it helps is when you have a multiplication problem, take your biggest number, which would obviously be the product, and that's going to be your dividend or what becomes divided. And then either factor can be your divisor. And what you have left over is your quotient. So lots of vocabulary to use here as we get used to that. All right, so go ahead and turn to page 357 and we'll get started. And for this one, if you could, just divide your paper into two equal parts here. We're just going to split that up because I want to show you a couple different ways to do this. So, first things first, let's read over the problem. Grant has 3.6 pounds of pretzels, or 3 6 tenths. He puts the pretzels into bags that each hold 3 tenths of a pound. How many bags does Grant use to hold the pretzels? So, for that, let's circle. You've got 3.6 pounds. We're going to split them up into equal portions of 3 tenths of a pound each. So here it's going to be 3.6 divided by 3 tenths equals something. We're not going to know for that one. And this is where we're going to take these numbers and to make things easier, if we shift both of these numbers, our dividend and our divisor, um, we can create whole numbers out of them. So we know 3.6 can become 36 tenths, and we know this zero point 0.3, we know that is 3 tenths. So we can do this different ways. So let's try, we can take our division problem and create a multiplication problem from it. So for that, we can do something times 3 equals 36. And you might know from your 12 facts that 12 times 3 equals 36. So we know that he's going to make 12 bags. Or if you factor everything out here and you create um, 36 divided by 3 equals something, you can either do that in your head. And well, you can do that in your head. I know at this point we should know our 12 facts, and we know the answer is 12 or 12 bags. So either way, um, You've got two different ways you can do it. Either way should work. All right, let's go and look at the next page. I'll go over these quickly. Um, the techniques here are showing us that you can use decimal grids. These squares here are decimal grids. We know each column is a tenth, and each individual cube is a hundredth. We just know that from practice. What I want to show you though is you can visually draw this out and then draw these red lines to break everything up into equal parts and just label underneath here. That's 3/10. 1, 2, 3. 3/10, 3/10. And this is something interesting. We have 1/10 here, and then we have 2 over here for a total of 3/10. So I kind of wanted to point this out to show you that sometimes when you're using models or grids, you might have to grab some from another grid to get a full portion. So just keep that in mind for that. And so obviously we've got 1 hole, 2 holes, 3 holes, and then this is 1, 2, 3, 4, 5, 6, 6/10. So that whole grid here represents that 3.6 pounds. And we're splitting them up into equal portions of 3/10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 bags right there. Another way to do it is like how we did it on the previous page. You can take this and solve it where you turn it into a multiplication problem. And I don't really have to go over this because we literally did all this stuff on the previous page. So let's look at the notes. And these are all on page 359. All right, look at picture it. That's the one with the grids. How do you decide what to shade? So we know that each large square equals 1 pound, and each column equals 1/10 pound. So that's how we know to shade in 3 full squares, and then we fill in 6 full columns to get that total 3.6. Why are the grids separated into groups of 3 columns? Because each bag holds 3/10 pound. Again, the column equals tenth of a pound. Model it is when we switch things around to make multiplication. How do you know this is a division problem? Um, the best way to answer that is this. We know, or basically what they're asking is like, how do we know that this is a case where we have to divide things? Because we know the entire amount, which is 3.6 pounds, and the size of each group. And that will be 3/10 pound. So once we have those, that's how we know we can do it. Explain why 3.6 is 36 tenths. The 3 ones equal 30 tenths plus the 6 tenths equals 36 tenths. Both picture and model it tell you that Grant uses 12 bags of pretzels And explain how to divide tenths by tenths. Show the tenths as whole numbers. And you should do just fine. Again, we're just making things that look a little complicated more familiar to us, changing them to whole numbers. All right, so we've got 3 examples to do. If you turn the page to page 360, I've got some different techniques we're going to try out. We can skip 7. All right, how many dimes are there in a jar of dimes worth $2.70? First things first, when we're dealing with money and we're talking about dollars, we've got dimes and we've got a total here. Let's write down the fact we know. We know there are 10 dimes in $1. That's just a fact. So technically, if we want to talk about decimals, a dime is a tenth. And if you add up 10 tenths, that equals $1. So again, money's a great way to kind of relate to decimals and wholes and all that stuff between dollars and cents. So if there's 10 dimes in $1, $2, that will equal 20 dimes. And then 70 cents, that will be 7 dimes. And we add them all up for a total of 27 dimes. Again, you could have easily um, done 10 into 270 and done it that way, but this is going to be more effective. All right, next problem. All right, this is another one where I want you to split your work area in half. I got a couple different techniques. A fence is 52 and 5/10 meters in length. Posts divide the fence into sections that are each 3 and 5/10 meters in length. So it's all equal. It wants to know how many sections are in the fence and show your work. So let's, on the left, set up traditionally. So 52 and 5/10 meters divided by 3.5 meters equals something. We know we can change 52.5 into 525 tenths. We know we can change 3.5 into 35 tenths. And over here, so now our problem becomes, actually, let me do this. So this now becomes 525 divided by 35. Let's set this up to traditional way. You could, I'm not sure any of you know what 35 times something will give you 525. So let's set it up over here. And sorry for my smartboard, you know how it is. Okay, so we're taking a 2-digit divisor and put it into a 3-digit dividend, which can be challenging, but we can do it. We know 35 will not go into 5, so I'm going to put a big red X there. But I do know I can fit 35 into 52. So I know 35 can squeeze in once. And now we've got to do, it's a bigger number here, so we've got to borrow from over here. So 12 minus 5 is 7. 4 minus 3 is 1. I've got to bring down this 5. And this is where we kind of have to do a guess and check and use some logic. To save time, I know 5 times 3 is 15. So I'm going to try that. And lo and behold, that gives me 175. So I got 5 here. And there we go. So our answer is how many sections? 15 sections. So again, you could take your number decimals, change them to whole numbers, and just do your traditional division. Last one. What is 42 divided by 7? We've got some options here. So just rewriting this here, 42 divided by 7. I'm going to change this into a multiplication problem times something equals 42. The good thing is I've got all these options over here to choose from, and I'm going to start with 60. Let's try 60 times 7 tenths. I've got one place value here, so that means I have to bring my decimal over here. And I got it on the first try, and I know that answer would be 60. So you also could have set this up as 420 divided by 7 equals something, and divide it like that. Zero, and that would have been 60. So again, if you change this to a 7 tenths, this can be 420, and then do it like that. So lots of different options. All right, your homework for today. It's going to be J5, divide decimals using area models and complete the equation. This is another one where the answers are all right there in front of you. You just have to figure out and kind of decipher the models and what numbers are being used for what. Ask me if you have any questions, and I'd be glad to help.